Thank you. So I guess it's better if I present in English to uniform myself to the others.
Sure, no? Whichever you want.
Okay. So I work at the Italian National Research Council after a long journey of, but you cannot see my presentation. One moment.
No, you can. Yes.
Okay. So this is the start. So I work at the Italian National Research Council, the Institute of Environmental Geology and Geoengineering, but we are a multidisciplinary institute, and we have a group on seismic risk, mainly focused on seismic microzonation, but we have also projects with the Department of Civil Protection regarding the ground motion scenarios for seismic phenomena, landslides, liquefaction, collapsal binding of roads and other infrastructure. Also, we are involved in many geophysical measurements, such as in Campi Flegrei. This is our website, just because generally people don't know what we do at the National Research Council. The motivation of this work is that there were many inspection campaigns on viaducts and bridges following the publication of the guidelines by Consiglio Superiore dei Lavori Pubblici for the classification and management and monitoring of existing bridges. And together with our colleagues of GR Consulting, which is a firm of civil engineering, they were carrying on extensive inspections on some viaducts and bridges of Italian highways, and in particular we have analyzed one case study, which is Stupino Viaduct, which is located in Salerno Reggio Calabria highway. It is a 600-meter long, 9 spans and 150 meters high bridge. It was designed with an isostatic configuration, so it has 3 central cantilever piers up to 130 meters, plus the external side spans are simply supported. And ANAS carried out extensive inspection and monitoring campaign, and it was stated that the conservation state is compatible with the age of the viaduct, which was built in the 60s. So the main degradation phenomena are corrosion, spalling of concrete cover. So, okay, so these are the, you can see here the main on one pier, the main degradation phenomena on the pier. So the construction technique, this bridge was designed by engineer Silvano Zorzi with a special technique with symmetrical advancement of pre-stressed segments with no supports, and the segments were cast in place and immediately pre-stressed. So it's an isostatic bridge, but with a very special construction technique. Here you can see a section of the cantilever pier with the deck, and you can see that there is a slope, and also there is a double deck with not symmetrical section. Here you can see in the next slide, you can see that a single pier carries 2 decks in the main part. So this is basically what I present today is basically the first step of a more complex strategy for implementing SSI, soil structure interaction in the model. So today I will present the development of a 3D structural model of the single piers with simplified soil structure interaction, but I will develop also more complex foundation models such as Winkler springs, and further studies will include complete modeling of the soil foundation structure system. So in the OpenSys STKO pre and post processor, I developed a model, basically is modeled with the shell elements with some simplification. So the road slope was neglected. Also the transversal deck slope was neglected for symmetry to avoid convergence problems, and the wall midlines were assumed aligned. And the model is elastic, the initial model is elastic, and the elastic modulus of concrete was assumed from inspection, in situ tests, so is measured. So these are the two models. One is for the two external piers, and this is for the pier 5, which is the highest pier. It was also, I also modeled a simplified model with springs, with the formulas by Gazzetas and Milonakis. The foundations are Casson's foundations. So there are springs modeled with elastic zero-length element, but as we can see here, the relevance, like in this simplified model, the relevance of putting springs can be almost neglected. And this is consisted with a wave parameter 1 over sigma of 0.06, between 0.06 and 0.09, because so this is the Casson foundations are basically act basically like fixed restraint. So it can be assumed that they are restraints if one models only one pier. Then I selected the two types of ground motions. On the top you can see simulated ground motions with less variability with a method that I developed, and also natural ground motions with higher variability. And this was done with a scenario earthquake of magnitude 7.1 and 11 kilometers of distance. So 10 records were selected and scaled for the natural, and the simulated, of course, are not scaled. This was done, okay, the simulated are simulated with this software Sigma that I developed. Here we can see the response spectra in terms of displacement. So basically we can see, of course, that for the response periods of the shorter pier and the highest pier, which are around 1 second and 2 seconds, it can be achieved the maximum displacement of 30 to 60 centimeters. So the displacement is not so small, also considering that there are hinges between the deck sections. So the deck sections can move horizontally. Okay, so these are the selected natural sclerograms. Okay, so these are the conclusions. So I developed preliminary OpenSys models of 2 tall piers from an existing isostatic multi-span reinforced concrete bridge in a highly seismic Italian area. The model analysis allowed to obtain periods of about 1 and 2 seconds for the 2 piers, with limited influence from soil structure interaction with this model. The seismic input defined through spectrum-compatible ground motions, the simulated accelerometers, sorry, I didn't say that, is that simulated accelerograms were generated because of the scarcity of records for large earthquakes. And so we can observe that the ground motion selection strategy integrates real records and synthetic signals from the Sigma tool. So the current elastic benchmark model will be progressively extended with nonlinear material models and a 3D or 2D, first 2D and then 3D soil domain, and to evaluate a more complex behavior of the model. And thank you.